So let's start. Just want to. Okay, so before we begin, questions about quiz and test. Did I mention about the midterm over here in the quiz last time? Did we go through it? No? Okay, so let me just quickly go through it and tell you what's going to happen. So you're going to have a quiz today. You're going to have a quiz this week. It was freaked up. You're going to have a quiz this week, and then you're going to have the midterm next week. We had kind of a query with the other class to see if they want to do the test the way I present this option, and if anybody has any objection, I'll listen to it. So this is what I want to do, and I want you to see if that's okay or not. So the quiz is quiz. You've done it already. You know what it is. First of all, you've noticed that I'm very, very slow marker. Like it takes me 20 minutes to mark each student multiplied by 100. That's the amount of time it takes for each quiz and test. So you have two choices. Number one, for me to mark you quicker, but then I'll give you the information about the test and the quiz and a midterm a day before, or I give you your marks later during the study break and after, but you get the information about the quiz and test 6 days before. So I can design those first and then continue marking. And everybody in the other classes down to this point said that give us the marks later, but give the information first. Is that okay over here too? You want the mark first or the information about, you know what? You know when I give you what the questions are for the quiz, so I can give you a few days in advance. Okay? Okay. People at home, you have to somehow respond to me. Probably in the wait, where? Let me bring it up. Let me go to the meeting. I'm going to bring the chat up. And we'll see how many people are actually listening now. So I'll go to the chat. Or actually, it's better to, you know what? If you're okay with me to give you the marks a bit later, but design the quiz and test earlier, raise your hand. Raising your hand is clicking on the raise thingy. I want to see how many people are going to raise their hands. Oh, this is much better. Okay. Keep going, keep going. All right. So far, 11 out of all of them. 12 of them. So everybody raised hands. Okay, good. Okay, so now you can bring your hand down. Just click again and it goes down. Okay, so that's that. That's saddle. That's number one. Down, hands down, hands down, hands down, hands down, hands down. Hands down. Okay, next. I'll show you how the midterm is going to be by bringing the midterm information thingy from last semester that I had. And again, we're going to see if you have any objection against it. You let me know. So this is what I want to do. So let me go back to this time. This is good. And I'm going to bring this up. So this will be how your midterm looks like. Okay, so midterm detail and policy and agreement is going to come up. Let me just do one thing in here before we continue. So this is what it's going to look like. So you're going to get something like this. So midterm programming details, policy integrity, midterm assessment details. I'll tell you what this is not going to be the question. So I'll design something and you'll see what happens. So I'm saying functions, you will be given functions for code doing this, templates doing that, example, given a class, yada, yada, and I'll give you an example of what a sample question is going to be. Coding style requirements, marking how it's done, and then you sign, and this becomes a prerequisite for your midterm, okay? Number 2, promising that I'm not going to make your questions bigger. The question is going to remain exactly what it's going to be, as if we are doing the whole midterm in one day. What I can do, and everybody cheered last semester, is to do the midterm and concept and walkthrough after the break and do the programming before the break, the programming part. So the concept questions and the walkthroughs and things like that, you do it the very first day you're coming after the break, because that's easy to mark. It's mostly automatic. I have to just go through it and make sure everything's fine. But the programming one, I'll do it before. What you are going to get out of it is more time. I have only 1 hour and 30 minutes, 1 hour and 40 minutes max to do both of them. If I do it like this, I can give you more time to do your programming. So I can give you around 90 minutes, 100 minutes to do your programming, and then I'll give you another 50 minutes to do your concept. But if I put them together, then you have to do them both in 1 hour and 30 minutes, 1 hour and 40 minutes, both of them. So you're going to have only 60 minutes for programming and 30, 40 minutes for your concept and walkthrough. So my question is, how many of you are okay to do the midterm and concept and walkthrough separately after the break, after the study break? Again, raise your hand so I can see if you like to do that after, but you're going to have the exact same. I'm not going to add anything. You're just going to have more time to do your programming. Okay, over here. Okay, he doesn't even care. That's okay. All right. Okay, so all right, and we have. Okay, 9 people over here doing so. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 4 people are not saying anything. So anybody have any objection to this for any reason? Like you don't want to do it because, people says, let's do the information first. No, that's fine, information first. But the other class said, could we do the programming after the break? No, you can't, because as I told you, I'm a slow marker. I need time to mark the damn thing, and then you're not going to be able to get your answer before the drop date. So it has to be before. And that's that. So you can bring your hands down. Thank you very much. So down, I'm going to give you the final results after I go with the last session too. Make sure everybody's 100% okay. Nobody has some like a fire alarm type of a thing saying, no, I don't want to do that, and we'll go through it. If you have any objection against this, you can privately contact me, and I'll see what the problem is and see if we can fix it, okay? So this is what's going to be programming before, concept and walkthrough after. You can bring your hands down. Okay. So now we can actually start the session. So this is how it's going to be, and yeah. And let's start. So we are going to talk about the standard library today, and then we're going to move into standard template library to see exactly what we are dealing with. So Um, we're going to talk about categories of standard library. We're going to talk about the string library, the string view library, compare compare it with the C stuff, string and see what they are. Talk about containers, iterators, and later in a probably week after the break, we're going to talk about algorithms and stuff. We're going to talk about an alternate to use unions, and that's going to be it. So we have categories that the categories that standard library falls into are these. So we have for language support, we have the standard library, and when we have new, that these are for new memory management, size D, bad alloc, and things like that. We have diagnostics, that is exception and standard exception library. We have general utilities for move semantics and optional values, utility, optional, and variant. We have strings, string and string view, it's for text management. We have containers, vector, list, map, set, DQ, queue, list, forward list, all these things that I'm going to go through one by one. That is essentially to manage data structures. We have iterators and algorithms. So essentially, iterators are kind of smart pointers that point to the elements of the containers. First of all, what are containers? Containers are simply alternates of using arrays. Many different ways, many different things to use instead of arrays to make it more efficient. We're going to go through every and each of them. We have numerics with CMath and numeric for math operations. IO stream, you already know, IO stream and F stream. Multi-threading, we're going to see it soon, which is essentially standard template library to be able to use and run applications, functions simultaneously with many different versions at the same time. So I write a function and I execute 5 instances of that function at the same time. And they are in thread and future library. We'll see all those things. So what iterators are essentially, as I mentioned, smart pointers, which we're going to cover later to see exactly what smart pointers are. But they are smart pointers that are to handle elements of an array. So essentially, you create an iterator to point to an element of an array. Then you can say, now go to next one, next one, next one, go to previous one. You can do stuff like this with it and makes it much quicker and faster. So these are the categories of standard template library. The string library. Essentially, what string library is a way to handle text in a easy memory leak free way. So what happens is that essentially a string encapsulates a C string in a way that you don't have to care about what is the size and all the things like that. So It's not C string, it's actually string, and you create an object of type string. It has a constructor that accepts a C string. So essentially, you deal with strings now like variables. You can say S1 plus equal space. So essentially, it concatenates the space to it. You can concatenate one string to another. You can display it with cout. You can see what is the size. The index operator is overloaded, so it can give you individual characters inside the string. And you have, you can see what is the substring from index 0 with length of 5. You can see where certain substring is inside your string, so it gives you the position for it, the index for it. And there is a value inside the string called NPOS, which is essentially null position, which any method of the string that returns an index for you, if it returns an npos, it means unsuccessful, which in find, it means I couldn't find the world inside the thing. You can replace at certain position up to certain characters with another string inside the string, so it does the replacement for you. And these are all the things that you can do. And I'll give you an MD file that has the list of all the good things that can be done with strings. So go through them. It's here. I'm going to put it at in the notes for today. So you can do concatenation. You can append one string to another, or use plus equal if you want to. You can modify characters, individual characters. You can use methods at instead of the index operator. It works the same way. So it gives you a safe access and check the bounds. It makes sure that you're not exceeding the bounds of the string. You can clear the string to empty it. You can see the size, and you can see if the string is empty or not by calling the empty function. You can find something in it. You can insert information inside the string. You can erase from certain position up to characters. You can replace the values, and these are all the good stuff you can do. So they literally created an object that handles the strings perfectly for you, and you don't need to worry about it. Okay? But remember, if you want to use cin's getLine with a string, you have to use the helper function getLine. So there's a helper function that accepts a string and iStream in it, any version of iStream in it, and it reads spaces into a string. Okay, keep that in mind. Because getLine is only for C strings, the method getLine, so they created a helper for it. Anyways, well, we'll see those. And strings are containers. Strings are containers, so strings are containers, so like any container, you can iterate through it using a range-based loop. So, and you can modify the values exactly like you are using a regular array. So what you can do, you can simply create a string, and then you can say for each character inside message, automatically traverses through it, makes that CH reference of each character of a string, and you can call the C types toUpper to make it uppercase, for example. Things like that. You can literally work with the string as if you're working with a character array of characters, but in a safe way. The next thing you need to know that it's in C++17, because strings were kind of heavy to be taken around. because strings were heavy to be taken. When I say heavy, it means that they literally are encapsulating an array of dynamic string in them, right? So they do dynamic memory allocation, they do all these modifications. They're very, very expensive to actually work with. But the problem is that sometimes you just want to do read-only stuff with your string. You have a string, you want to print it. You have a string, you want to search something into. And passing this string around is extremely expensive with lots of dynamic memory allocation and things like that. Okay? So if you don't want to move it and you want to pass it around, then it's better to have some kind of a read-only string passed around. So what happened is that after C++17, they created this lightweight string. They call it string view. So what string view is, it attaches itself to a regular string and only does read-only stuff with the string. So what it does is something like this. Take a look. So as you see, let me just bring the code. Again, this file, I'm giving it to you. Please go through it. So as you see, you can pass a string as, where is the thing? You see that? I am passing a string to a string view. What happens doing something like this, it sets the string view to view the data of string. And you can do all the little stuff that you want to do with it simply in the string view with absolutely no problem. So if you create a string view and you create a substring of another thing, you can go through it and treat that piece of substring of the string as a string view. The important thing is that when you're actually working with a string view, you do not have write access to it. You can search in it, you can look and find stuff in it, you can see what is the substring of something. So using a string view, either you can have a regular null terminated string array of strings to do search and stuff in it, or you can use a regular string. It is extremely lightweighted and it's not going to cause any overhead. So it is very, very useful. It has a catch though. So string view is ideal to use when you don't need to modify the string. So when you don't want to modify the string, putting it in a string view make it faster and lighter and better. There is one thing that you need to know, and it is non-owning. It means it doesn't own the data. Also, this is just another example for it. Also, let me just see ABCDE string. Also, it is important to know that when you have a string and you put it inside a string view, so essentially string view is viewing a string, you should not modify that string and then use the string view after. Because string view is looking at the data of the string. If your string modifies the text, it might reset the address, and string view is still looking at the old data, and everything gets screwed up. So if you are using the string view like this, life is beautiful, no problem. I want to take a part of a string and deal with it and work to see how it works. I want to find a specific thing inside a string using a string view, that's very fine. But if something like this happens, it's going to be dangerous. Let me bring it up. Take a look. Okay? So what happens if I write this? I'm saying string is text. I'm going to go OOP345 rocks, and I'm going to say view is going to view that text. Now I show the view, and it's going to say OOP345 rocks. But if I update the text, then what's going to be the value? It should be updated, right? If I show the string, it's going to show updated. But what happens when I show the string view? Look at that. It's not null terminated. But we are lucky because updated is smaller than the text. The string is smart. String knows because it's smaller, I'm not going to reallocate memory. But if your value becomes bigger, then it's completely reassigned and reallocated. And because of that fact, it is completely garbage now. Because now it is bigger, it had to delete the old one and reallocate new one, and because of that you have no access. Remember, when you are using string view, if you have modified something, you have to reset the string view to look at the new string again for it to use it, okay? You have to always update it. Again, it's non-owning. It is extremely important to remember that. It doesn't own its data. It looks at other strings data. Okay, now, standard template library. With standard template library, we have containers, we have iterators, we have algorithms, and we have function objects. So these are the things that work within standard template library. Containers are essentially structures that hold the data, like vector, map, set, all the good stuff. Iterators are objects whose job is to keep track of the element of these containers. Algorithms are functions that get these containers and do some processing with the data, standard processings that are out there. And functions objects are literally functors written to do operations you want to do with different types of algorithms. And when we come to it, you'll know exactly what I'm talking about, okay? So you created, remember we created lambdas when we want to actually do something inside we pass a lambda value to our validator to do the validation. Instead of doing that, there are functors written that do that. There's a functor called less. So you can send the less functor for two integers, and it automatically, it's as if you have written a function. So all the standard things you need to do in C++, there are functions objects written for it to make things simpler. But these are all templated stuff. And just an example for what we're going to see in future, we're going to deal with stuff like this. For example, you have series of integer values. You want to sort them. You say sort from beginning to the end. So beginning is essentially an iterator pointing to the first element. End is an iterator to pointing after 3. Okay? Then I say, for a range of I can show it, then I can do a binary search from the beginning to the end and look for the element 3. If it's there, it's going to tell me it found it very quickly. So imagine, instead of integers over here, I had students. And I overload the comparison for students based on their name or based on their student number. So when I sort them, because sort does comparison, automatically students are sorted by their student number. Then I'll do a binary search for all the students, and I put a student number here. As long as the comparison operator is overloaded with student and a student number, you can quickly find out with using a binary search. So these are all standard template library that you can use for everything. Everything. So this binary search, because nums is an integer, it searches for integers. If you had students, it will search students. It doesn't make any difference. It's just templates. So everything, anything that you can think of that you want to do in your application, there is some template written for it that can help you do the process quickly. We learned that we can create a union to put stuff in the same piece of memory and then looking at it in a different way. So we said that we could have something like this. We could have, I'm just take these up. I can have something like union of mixed. And in this union, I can put an integer, and I can put an integer val and a double dval and a character CSTR5. I can put these together, which means val and dval and this array of characters, they are all at the same place in memory, which means if I put something on an integer, the double value will get ruined. If I put something in a double, so I had to actually go through the union and try to get the values out the way I wanted to. This is not safe. You know why? Because it's just, you have, the size of this thing is 8, but your integer is val that is only using the first 4. So you need to understand lots about memory and how the things are organized to be able to do it. And if you put something in an integer, you can extract the value dval. Nothing's going to prevent you. You're going to get garbage, but you can. If you put something in a C string and extract the value, obviously it's overwritten by that, and garbage value is going to come out. But you can do it. So what they created over here was what we call a variant. A variant is another template in standard template library whose job is to overlap information. So you can say, I want a variant of an integer, double, and a string. V equals to 3.14. When you do that, it knows it has to overwrite the double, not int or a string. It knows it. And if you say get double V, it's going to give you 3.14. If you set then V to a string, it knows it's a string, so it's going to put it on a string, and if you get string V over there, it actually gives you the string. And the beautiful thing about it is that if you try to, and if you say V index, it's going to tell you which, hello? Okay, please. Okay, so I heard myself teaching. Okay, so what I was saying is that when you actually say v index, it tells you which one was the last one that was set. So the index of the string, so 2 is going to get returned, which means now 2 is the one, the string is the one that is actually you're dealing with. All these things apart, the most important thing is that you can say try cout and if you do something that is a bit bananas, it will actually throw an exception for you. And that exception would be bad variant access. So you can freely work with your variant and extract the value that you want, but if the value that you have extracted is not the one that was set last one, it will throw an exception. You can actually detect something went wrong in there. Okay, so it actually throws an exception, but that doesn't happen with union. So it's a safer way of using a union. Now, containers. We have several different containers that we need to understand them all and see exactly what they do. So I'm going to go through them one by one, give you examples of it, and hopefully we understand how they work. First of all, let's understand that containers are literally replacement for arrays, different structures of data being kept in memory. When I have an array, arrays are sequential. I have an index that I access them. If I pass the index, I pass the thing. I'll go to someone else's memory. It's going to crash. When you create an array, it has no idea what is the size of the array. So size of the array is not accessible. So it's pretty low level, like C, right? Now, if we want to make it high level, we need to be able to actually create different types of wrappers around the array to keep the information and the elements in a proper way in memory and access it the way we intend to. So depending on how you want to access the data, you create the proper container for it. Containers are in 3 different categories. Number 1, we have sequential containers. So types of containers. We have sequential containers like array, vector, dequeue, list, forward list. These are the containers that are sequential in memory. They work like regular arrays. Then we have container adapters. Container adapters are not new objects. They are classes wrapped around sequential containers. So stack is essentially a wrapper around list. A queue is wrapper around list. A priority queue is wrapper around vector. So it's a wrapper around already existing containers to allow you to do only a specific type of action with it that comes with that structure. For example, a stack is first in, last out, or last in, first out. A stack is, you know what a stack is, right? You stack the stuff, like you have a stack of plates. always the last plate that you put over there is the first one that you're picking up. That's a stack. So if you want that type of structure, you create the stack container. And then we have associative containers. Associative containers work with association between elements. Like you want to have an element, you want to have a container of elements that repeated elements are not allowed. Or you want to have pairs of key and values held in a container. Things like that. Set, map, and stuff like that. So these are associative containers, and we're going to go through every single one of them. So, array. So we literally have a container called array. So how the array works, you mention what type of array you want, you say what is the size, that's it. You're stuck with that, and you have no other choice. It is literally a wraparound C array that you have. You get its size, you can see what is in front, what is at the back, you can use range-based group to go through it, you can modify each element using the index operator like a regular array. Okay? So that's like the most elementary type of containers that we have. They have fixed size. They are stored in stack, not heap. What is stack? Anyone? Stack is the piece of memory that is within your executable, and so essentially when you add values, it grows the size of your executable. So that's essentially what it's the memory in which your program is getting executed. It's very limited. Heap is the memory that is shared by all the executables. It is not in there. It's in the stack. And it supports front, back, fill, at, and all the methods that we're going to see one by one. Let me just run it, make sure it works. So as you see now, the size is 5. The size is 5. The front is 1. The back is 5. And you can modify one of them. As you see, I put 99 in there, and that's that. Simple and straightforward. You can use the at method. At is essentially like index. You can write noms.at2, which is going to be this one. Okay? So essentially gives you that one. The difference is that that at makes sure that you're not, it checks boundaries. So that's array. The next one is the most commonly used container in C++. It's called a vector. So vector is contiguous, which means like an array, all the elements are back to back in memory, which means if you have the address of the first one, you can go by the address and have access to it very quickly. Essentially, they say whenever you want to use any type, whenever you want to use an array, use a vector instead, always, okay? It automatically resizes as you push back or insert. So if you push back method, if you call the pushback, it adds to the end. If you use insert, it inserts it after a specific iterator. As you see over here, I'm saying students begin. Students begin returns an iterator. Essentially tells where is the beginning of the array. When you do +1, plus is overloaded, it means go 1 element further. When you say +3, it's overloaded, it means 3 elements further. Okay, if you say pop back, it actually removes the one from the back and either returns it. If you don't catch it, it throws it away. So you can actually remove stuff from it and you can go back. So essentially you can use a vector like an array with index, there is no problem with it. You can say student 0, student 2, you can use that, there's no problem. But it's very fast, and it's best for fast lookups and append operations if you want to append stuff to a vector and change the size. Uh-oh. Control C. Sorry, this is the vector. There we go. So that's that. And what I mean is that you can literally use it like an array. You can literally say for size t I set to 0 and I less than students dot size and I plus plus. You can literally do this. Cout students I. There's no problem with this. You can use it literally like an array. No difference. Okay? Now we have another one that is it's called a DQ. Okay? DQ is what we call a double-ended queue, which it is not contiguous in memory, which means it's all over the place. It depends when it's setting it up, it knows where to put what to put where. Okay? And because of this fact, it's not very fast when you want to actually traverse through it and loop through it. Okay? It's the main purpose that you want to use DQ is for fast insertion and removal on both ends. If you want to be able to quickly remove something from the head of the queue, or insert something to append something to the end, or vice versa, that's your friend. DQs are amazing to implement sliding window programming. Sliding window programming essentially means you have a stream of data and you want to look at a piece of data at a time, and you want to slide this thing around on your data back and forth. This is a good thing for it. Like history, you want to create a history for a browser. This is a good thing to use. Okay? Or if you want to use a text editor with lines and you want to scroll up and down and see what it is in there, or a list of information that you can go up and down and scroll, that's a good thing for. It's not good for quick search, but it's great for sliding windows, queues, and history buffers. You know what does it like? That literally pop and push, it literally means what it says. So when I say over here, I have 10, 20, 30, then I'm saying push front, it adds the 5 to the front. When I say push back 40, 40 goes to the back. So it adds to the beginning and end. If I say pop front, it removes one from front. Pop back, it removes back. It returns it. You can actually grab that value if you want to. And that's what it does. It's a very useful thing for insertion and removal at both ends. Yeah, I'm going to go DQs here. lists. It's doubly linked list. It's a doubly linked, they call. It's implemented in that way, which essentially is you're gonna learn this in data structure. So when you create a list, this is what's going to get created in the memory. So essentially, you're going to have, for each element that you're putting in here, there's going to be a node created, okay? There's going to be a node created. And the node that you are creating works like this. So one is over here, one is over here, and one is over here. You don't know where they are. Each one of these nodes, they have 2 pointers. And each one of these is aware who's next and who's previous. So essentially, this points to next. Doesn't matter which one is next, okay? This points to next. And the last one points to nowhere. And each one of these know which one is the previous one. So this one's previous, this one's previous, and this one is pointing to nowhere. But when you create the list over here, what gets created is actually a completely separate object. So this is your that you created over there. And this list of yours, depending on what is the standard that they go through, usually you have something like this. So they have a head that points always to the beginning. It has a tail that always points to the end. And it has a current that points to the one you are dealing with. Now, it could be any of these, depending. So if you are here, the iterator is pointing to here. You can go to next. You can go to next. So something like that, okay? Because of the way it's actually arranged in memory, it has lots of overhead. For each piece of data, you have to have 2 pointers to point to the previous and the next. The beautiful thing is that insertion, removal, and editing the elements, they rock. Like if you want to insert a node in the middle, there is no problem. Like if I have a new node that I want to insert, whoops. If I want to insert a node somewhere, let's say between these two. Between these two. If I want to insert a node between these two, what do I need to do? It's very simple. All I need to do is to make the previous point to this one, make the next point to that one, make the previous point to this one, and make the next point to that one. And remove these two. I just inserted a node in the middle of my array. Now it became 4. You see that? And I did not shift or move anything. So it's very efficient to add stuff anywhere you want. But it's extremely slow when you want to traverse through it. So there is no index operator here. You cannot say, I don't know, members I, like members 5. You can't do that. One by one, you have to create an iterator. And as you see in here at line 11, I'm doing it. I'm going to say I have an iterator that points to the beginning. Now I'm going to say advance that iterator twice. It means go twice further. Now I'm going to say list, and I'm going to, so as you see, this is how it works. As simple as that. In the, You can remove stuff out of it. So I can say remove 25. It searches for 25 and removes it if there is any. If it doesn't, nothing happens. So it's very efficient with insertion and removal. This is called a double E. This is called a list. Now they make this even lighter. They make this even lighter with a forward list. A forward list is exactly like a list, but the difference is that, let me just bring it up first. A forward list is exactly like a list, but the difference is that each node has only one pointer. So your node looks like this. Therefore, access is one way. Access is one way. It comes to here, it goes to there, and the last one is null. There's no going back. You can always go forward. How it works is that the forward list class, has only access to here. And then it has obviously a current one that can go only forward. So it can go from here to here to here. So, but it cannot come backward. If you want to come backward, you have to start from the beginning again and go forward. So if I am at the third one and I want to go on 2, it's very expensive. It means first I have to come back, then I have to go forward until I go before this one. It's very, very tough thing to do. So it's lightweight. So why do we use this? Because you save memory, you have only one pointer, you only traverse forward, and it's best for lightweight streaming style structure, that the data keeps coming and you want to get it and you don't want to go back. So what I just told you, all the things that I told you over here now, are essentially the first type of container that we had. There were sequential containers. These are all sequential, and they keep the sequence somehow to keep track of things. Okay? Now, for the next, let's take a break for 5 minutes, and then we're going to continue for the rest of the stuff. I'm going to resume with this one, and resume here. Okay. So now we are talking about container adapters. So these are not new stuff. They're all wrapped around other containers. A stack is a last in, first out, and it only has push and pop, and that's it. So, and to see if it's empty or not, you can see if it's empty, push and pop. So these are the 3 main things. Data structure stack is like that. You create a stack of anything, you keep pushing stuff in it and popping stuff out of it, as simple as that. There is no other mystery behind it. That's a stack. Simplest thing, element O. Although stack is the simplest data structure, but if stack wasn't there, we couldn't call a function. Every single function call that you have is literally a stack, a push into a stack. So when a function is called, it sees where the address of the current function call is. It pushes that one into a stack. Then you go to the function, it calls another function, again pushes the address to the stack. So always the last function called, its address is in the stack. And a return statement in your function call is essentially a pop. So when the program reaches to a return of a function, it pops the address to stack, therefore it knows where to go back to, and then continues another return, pop, another return, and when the stack is empty, it means you're in main. As simple as that. So the stack, when you're doing programming, when your program is running, the stack, the function called stack keeps growing and shrinking until it goes back, and then that's the main. When it goes to 0, that's main. There is another one called queue. So queue is essentially always you add, queue is a lineup of Tim Hortons. Okay? So when you push, when you get into it, when you push, it always pushes to the end of the queue, and when you pop, it always extracts it from the beginning of the queue. It's literally a lineup. So we call that first in, first out. The other one is first in, last out. This one is first in, first out. So whenever you have that situation, that's the adapter you want to use. And the next thing is a priority queue. Priority queue is a queue that always keeps the largest on top. When we say largest, it depends on you. What do you want the definition of largest to be? Did I save this? Yes, I did. So a priority queue, if you are creating a custom type, you have to make sure your custom type has the comparison operators overloaded. If that's the case, anytime you push any value into priority queue, it always keeps the biggest one at the top, and always the smallest one will be at the bottom. It's a priority queue. This is usually done for queues that you want the jobs with priorities to be done in it. Say you are at the airport, you say kids and seniors are going to go first, then the first class is going to go, then the economy is going to go, then rows from this and that. Those are the priority queues. So you can have repetitive information in here, there's no problem. You can have 50 stuff over here, and out of this 50, 5 of them is 100, and I don't know, 90 of them is 10, and another 5 is 2. So it's going to push everything in that order. Always the biggest one will be at the top. And you have a top method over there to extract the value with. That's called priority queue. So a stack behind the scene is actually a DQ container. A queue behind the scene is a DQ container. And priority queue behind the scene is a vector. Other containers that are important to know are and these are associative containers. Set. With a set, you cannot have repetitive element. So when you overload the comparison operator, if the value that is being inserted compared to another element returns true, it will be ignored. In here, as you see, I have 10, I have 30, 10, 20, 25 will be inserted. First of all, when I set when I do the set like that, it's gonna first sort it. So 10 is gonna come to the first, 20 is gonna go second, 30 is gonna go last. So it's always sorted. A set is always sorted. Then, when you insert, it inserts the 25 between 30 and 20. That's where it's going to get inserted. And when you insert 10, it's going to ignore it because it already has a 10. That's how sets work. Okay? And find in a set is extremely fast because it's a binary search find. So it immediately tells you if it finds it or not. And the iterator that it returns tells you where it is. So when we learn what iterators are, you can extract the iterator from find, and it tells you exactly where the object is and how you can access it. And that's that. And obviously, range-based loop works for this one too, because it's a container. So at any moment you want to have unique values kept, set is your friend. Dictionaries, phone books, key and values. If you want to hold, you use a map. A map container is actually one of the coolest ones. I've used this in so many different things. Works like this. So you tell to map what you want to pair. I want to pair strings and integers. So what happens, it pairs them together, and whenever you are adding a value, okay, you add it like that. You say phone book, Alice, 1, 2, 3, 4, phone book, Bob, that. So next time when you extract the value from Alice, 1, 2, 3, 4 is going to come out. It's an amazing thing. You can add pairs to it and access it very quickly. It actually accesses the value like that. So it creates a dictionary for you. That's called a map. Now, iterators. What are iterators? Iterators are custom pointers. We call it smart pointers. You'll see what it is soon. That point to the elements of any type of container. So, and within each container, an iterator class is created that you have to use that to instantiate it. So if I say vector int iterator, the IT over here is the iterator to a vector of integers only. Obviously, begin is one of the methods of vector and all the containers, which actually returns the very first iterator in your container. So if I say iterator IT is equal to begin, iterator not equal numbers end, and end returns one after last, not the last. Last is begin minus 1. Remember. So I can write a for loop saying start from the iterator numbers begin to not to be that, and plus plus IT. So plus plus and minus minus, postfix and prefix are overloaded, and they essentially give you the next and previous iterator after the current one. Target of is overloaded, so when you put target of beside it, it actually becomes the element itself, and the iterator, it works that way. So It's as easy as that. They made it look like pointers. They're not really pointers, but they made it look like pointers. So plus, plus, minus, minus, and plus and minus operators are overloaded for them. And the target of the dereferencing of the iterator is overloaded too. Obviously, we could have written it like this. Right? So when you put auto, it automatically takes. That's why everywhere we use auto for that. Essentially, when you're writing auto, that's what it means. Okay? A reverse iterator is an iterator that gets the beginning. The beginning of a reverse iterator is the last element of the container. And the end is the very first one. It literally reverses the iteration if you don't want to do minus minus. So with a reverse iterator, I can say auto IT is numbers are begin and are end. And if I do it like this, it reverses. Okay? So our reverse iterators go backwards in a container. Now, you can extract constant iterators from a container. You can extract constant iterators from a container. If you want to pass it so say you want to pass an iterator to a function to traverse through something, and you want to make sure that it's not going to change. Constant iterator, it gives you read-only access. But if you want to use auto, then they created this. So if I want to have automatically so if, let's put it like this, if number is a constant, so if I pass a constant reference of an integer set to a function, to be able to traverse through it, I have to create a constant iterator for it. Or if you want to put auto over here and you want it to be a constant, you add a C at the beginning. So automatically, you have to say constant begin and constant end. But if you want to create a constant, you can say constant iterator begin. So either create this as a constant and receive whatever you want to into it, or if you want to use auto, you have to say, give me the constant one out. So passing constant containers back and forth, you can use this. But if a constant container is passed to a function, you cannot extract numbers begin. Because it's a constant, begin doesn't work with it. So remember, vectors, fast access, sequential data, lists, frequent insertions and removals, DQ, insert, remove at both ends, set, sorted at all times, map, key values. These are the things that we have. They're all in the notes. Please go through them one by one and run it and test it and play with it. And then we have helper functions, utility functions for iterators that we are going to talk about the next day. Okay? It's a little too much for today. I gave you already millions of stuff to do. Well, what utilities are is like, for example, if you have two iterators created, one to the beginning and one to the end, you can see how many elements are between the two. It's called distance. So if you call a distance function, you pass two iterators, it tells you what the distance between the two are. Something like that. Or you can advance it how many times you want. You can see which one is the next, which one is the previous. Well, we'll come to it later. I'll explain. So, that's that. Any questions?
Yeah. If a set is automatically sorted, does that mean you only use numbers?
No. You use any type of custom type that you overload the comparison for it. Oh. So the set has a tool to compare the two elements. So if you have students and the comparison between two students, the overload of comparison between two students, less than, greater than, you implemented all those, compares the student numbers of the two students. When you insert them into set, they're going to be sorted based on their student number. If the comparison between two students is comparing their last name to compare two students, when you insert them into set, they will be sorted based on their last name. Got it? Does that make sense?
Yeah.
Okay. Anything else? But the things you are doing should actually make sense, especially when you're using set. Like if you are doing comparison between two students and you are comparing their student number, you have to make sure that the equality does the same. So if you do less than and greater than, comparing the student numbers, but to check if the two students are the same, use their last name, then the set's going to get screwed up. You have to make sure they're all set properly. It should make sense, let's put it that way. Anything else? Okay, please run the codes that I have put over there. They are designed to be very small and easy to run, and just add stuff to it, play with it, break it, see how it works, and come back with questions. Okay? Are we good? Online people, questions? Suggestions? Objections? All good? Have yourself a beautiful, beautiful day. I'm going to push the codes in.